In this video, you are going to be learning about rotations and how to do that on a coordinate grid. So the number of degrees a figure rotates is the angle of rotation. That's denoted with a lowercase x and a degree symbol. That will be the angle of rotation. And then a rotation of x degrees about a point P is called the center of rotation. So in order to rotate, you need to have an angle of rotation and you need to know what point you're rotating about. And a rotation about a point is a rigid motion, and you can write x degrees rotation of triangle ABC about point P as a lowercase r and then a subscript with your angle of rotation, x degrees, comma, your point P, and then that is telling you that you're a rotating triangle ABC. And once you rotate it, that's going to give us our image triangle, triangle A prime, B prime, C prime. And in this class and in this situation and in this video, the x degrees is the number of degrees a figure rotates counterclockwise unless stated otherwise. So next we're going to take a look at the difference between clockwise and counterclockwise. So first I'm going to do clockwise. Clockwise is just the direction that the hand goes on a regular clock. So I'm going to start at 12 o'clock and that's going to be moving clockwise in the clockwise direction. So that's just how a normal clock will move. Counterclockwise will go in the opposite direction. So starting at 12, it goes the opposite direction. So that's going to be counterclockwise. I'm going to be using clocks to help us with the representations of the rotations, and so I'm going to show you how the angle of rotation correlates with the numbers on a clock. And so I'm going to start with clockwise, and I'm going to start at 12, so that will represent 0 degrees. And then from there, I'm going to move to 3. And by doing that, that means I have rotated 90 degrees clockwise. And then to go to the 6 o'clock, that will be 180 degrees rotation clockwise. And then when it gets to the 9, that would be 270 degrees clockwise. And then getting back to 12, we have completed a 360 degree rotation clockwise. So let's look at counterclockwise so that you can see kind of the difference. So starting at 12, that will be 0 degrees. And then going to the 9, that will represent a 90 degree counterclockwise rotation. And then going to the 6, that will represent 180 degrees counterclockwise. And then the 3 will represent a 270 degrees counterclockwise rotation. And then getting back to the 12 will represent a 360 degree counterclockwise rotation. And notice that 270 degrees clockwise is the same as 90 degrees clockwise, 90 degrees counterclockwise. You are going to end up at the same location. And then similarly, a 90 degree clockwise rotation is the same as a 270 degree counterclockwise rotation. And notice that the 180 degrees, it doesn't matter if you're moving counterclockwise or clockwise, you'll end up at the same location. And same thing with 0 degrees and 360 degrees. So let's do an example. And it might sound confusing at first when I do the first example, but I am going to do 3 examples in this video. So hopefully by the 3rd example, you kind of get what's going on. So what it's saying here with the notation, with the function notation, it's saying we're going to graph the rotation of triangle KJI 90 degrees and it's comma O, which that actually represents the origin. So the first step with graphing the rotation of triangle KJI, I'm going to plot my point of rotation, which will be at the origin, which I plotted it right there. And then my next step is I'm going to go through and I'm going to figure out my horizontal and vertical distances to each point. And I'm going to use the clock. I'm going to keep the clock there to kind of help you with the rotations. So let's start with point point K. And K is pointing towards the 6 o'clock, the 6 on the clock, and it's pointed down 3 units. And so when I move 90 degrees counterclockwise, I am going to be moving to the 3 o'clock. And I have to still move 3 units as well because the distance will not change from the point of rotation. So my new K prime is going to be located right there. All right, now let's look at J. So I went up, and that's pointing towards the 12, 1 unit, and then I went to the left, 4 units, and it's pointing towards the 9. So when we do a 90-degree counterclockwise rotation, the green arrow is at 12, so when we go counterclockwise, it'll be pointing towards the 9, and I still have to go just 1 unit, and so that will be right there. And then I'm going to follow with my red arrow, and it's at 9, and so when I rotate it, it's going to be pointing towards the 6 on the clock, and it's going to be pointing down 4 units. And so my new point J becomes J prime right there. Okay? All right, and let's look at I, point I. So point I, you go 5 to the left, and it's pointing towards the 9 o'clock. And then I go down 2, and it's pointing towards the 6 o'clock. So when I do a counterclockwise rotation, 90 degrees, the purple arrow is going to move from the 9 to the 6 direction at the same amount of units, so 5 units, but this time it's going to be going down, and then the yellow is at the 6, and so then it gets moved to the 3 o'clock direction and 2 units. And so I prime will be located right there. And then to complete this answer, we have to connect our points. Okay, so let's look at example 2. And this is saying we're going to graph the rotation of triangle TUV 180 degrees counterclockwise about the origin O. So the first step is to plot the origin, which will be right there. And then the next thing is I'm going to figure out my horizontal and vertical distances to each point, and I'm going to use the clock to kind of help me figure out what direction I'm going to be moving in. And so I'm going to start with point T, and point T is 3 units up, pointing towards the 12 on the clock, and then I go 1 to the right, pointing towards the 3 o'clock. When I do a 180 degrees counterclockwise, it doesn't matter with 180 degrees, it's counterclockwise is the same as clockwise. And so the blue arrow is going to be, since it's 180 degrees, it moves from the 12 to the 6, so it'll be pointing towards the 6, and it's going to be going down 30 since it went up 30. And then from there, the red arrow, instead of being pointed towards the 3, it's going to be pointed towards the 9. And so my T prime is going to be located right there. And then next I'm going to do point U. So point U, I go up 4, and that's pointing towards the 12. And then the yellow arrow is going to the right 2, and it's pointing towards the 3 on the clock. So when I do the rotation 180 degrees, the green arrow will be pointing towards the 6 o'clock, the same amount of units, so 4 units down. And then the yellow from there will be from the 3, it'll be moved towards the 9 o'clock, the 9 on the clock. So my U prime will end up being right there. And then last on this, my point V, I am going to the right 4 units, so it's pointing towards the 3, and then I'm going to go up 1, and it's pointing towards the 12. So doing a 180 degree rotation counterclockwise, my purple arrow was pointing towards the 3, so now it'll be pointing towards the 9, and it's going to be going to the left 4 units, and then my upward arrow pointing towards 12 will be now pointing towards a 6. So from there, and I go down 1 unit, and so that will be my new point V prime. And then last, to answer this question, I need to connect the dots to create the triangle. Okay, last example, example 3, we're going to graph the rotation of triangle JKL 270 degrees counterclockwise about the origin, which will be located right there. And remember from earlier, 270 degrees counterclockwise is the same as a 90-degree clockwise movement. So I'm actually going to be doing that instead of saying the 270 degrees counterclockwise each time. Okay, so I'm going to start with point J, and I'm going to figure out my horizontal and vertical movements. And so starting at point J, I am pointing towards the 12 and it's up 4, and then I am pointing towards the 3 and it's right 2. So when I do a 90-degree clockwise rotation, which is the same as a 270-degree counterclockwise rotation, if I'm starting at 12 and I'm going 90 degrees clockwise, I'll end up at the 3 o'clock location. And so I have to go to the right 4 because the blue arrow went up 4. And so next I'm going to do the red arrow, which it's pointing towards 3, 2 units. And so when I do the rotation 90 degrees clockwise, it'll be pointing down towards the 6 o'clock. And so my new J prime will be located right there. And next I'm going to do point K. So K is up 5 units, and that's pointed towards the 12 o'clock. And then I go to the right 4 units, and that's pointed towards the 3 o'clock. So when I do a 90 degrees clockwise rotation, the yellow arrow will be going towards the 3, and it's once again has the distance and the length of the arrow cannot change, and so it's going to still be 5 units, but this time it's going to be pointing towards the 3. And then the green arrow is 4 units, and it's at 3, but when it gets rotated, it'll be pointing towards the 6. And so I'll be going down 4 units towards the 6 o'clock to get my K prime. And then last point, to get my L, I'm going to go up 2 units, so pointing towards the 12, and then I'm going to go right 3 units, and so that's at the 3 o'clock. And so when I do a 90 degrees clockwise rotation, the arrow pointing towards the 12 will end up pointing towards the 3 now, and it's the same distance, so 2 units now to the right, and then my orange arrow is going to, it was at 3, and now it's going to be pointing towards down to the 6, and it's going to be 3 units down, and so my L prime is going to be located right there. And then the last step in graphing this is that you need to connect the points.